Welcome everybody. Check the time. It's 9 p.m. 9 p.m. It's office hours time again. Thank you for giving up your time. Hope you've had a great day, or you're about to have a great day, or wherever you are in the world. It's been a beautiful day here in Perth. Spring is sprung, spring is springing, or whatever the term is. So the weather's been good. Don't have to wear too many jumpers. The heating inside the house is not on. My dog is happy. It's all working out pretty well. Hopefully you're all having good times as well. Hopefully we're all sort of coming out of the other side of what's been a pretty rough couple of years. We've got a lot to cover tonight and a lot of bits and pieces of news. There's obviously been a lot of new releases coming out of bits of software. So we'll get stuck into that. We'll cover that off in a bit of a news update. And then we'll get into your questions as well. Lots of things to get through. As always, we'll struggle to get it in the hour, but we'll do our best. Let me share my screen and we'll get straight into it. Hopefully you can hear me, hopefully you can see me, and hopefully you can see my screen. Getting in touch is really easy. Just head over to linktree/Connor or just scan the QR code. Anyone that lives in a contact tracing country will be very familiar with scanning QR codes. Every time we go to the shop or the service station here, you've got to get your phone out. But yeah, so if you want to reach out to me on Twitter, my blog, my YouTube channel, my podcast, etc., Instagram, Facebook, it's all there under linktree/Connor. I love talking technology, so please reach out. As always, if you're new to office hours, I always say, please do not adjust your set. I put all the content down at the bottom left such that when we turn this into a video on YouTube, it puts me at the top right and the content sits down at the left. There's nothing worse than those things when you go to webinars and that critical piece of code has been blocked by the speaker. So I try to shift everything down to the left, therefore you won't miss out on anything. Let's get into what I call bits and pieces, call it a news update, etc. Here's the first one. Once again, I always do a bit of a shout out to my local user group. All through winter and now into spring, we run this thing called the webinar series. I think it's every week or every couple of weeks. A speaker from around the world contributes a wonderful piece of technical talk, often relating to Apex. It's sort of focused in the Apex people that run it. But yeah, some fantastic stuff there on the Apex user group. This is what I'm doing in the next few months. I've been successfully selected for the Oracle Groundbreakers EMEA tour, which is coming, a virtual tour. Hopefully next year it'll be a real tour. So I'll be doing some talks in, excuse my butchering of any pronunciations here, Tajikistan, Latvia, Kyrgyzstan, and Azerbaijan, all virtual events. So keep your eye on that website. Lots of good speakers there, and that'll be a good, fun virtual event. Also, I was going to be speaking at the East Coast Oracle User Group. One of the benefits of virtual is the ability to actually do talks on the other side of the planet. Unfortunately, due to COVID, that's been deferred till February next year. I think it'll still be a virtual event, but in either way, sad news there, but hopefully East Coast Oracle User Group will bounce back. Also, I'll be doing some talks for the Latin America Oracle user community coming up soon. Stay tuned, it'll be sometime around November. Once again, we used to go on these Groundbreaker tours to South America, which some of the most magnificent hosts you'll ever find. Shout out to Edelweiss, Nelson, Rita, Roland, and Alex, and numerous others. Always made me feel welcome in South America. This time will be virtual, but hopefully just as much fun. And I'm speaking literally Tuesday, just a few days' time, at the UKOG Tech Summit. That's I think it's an explicitly virtual event. And I'll be talking there about read consistency, Oracle's core signature database feature. Also, you may have seen the UKOG are holding an in-person event at the end of the year. So if you are in that neck of the woods, please get along. User groups need our support. Also, the big one, no open world this year. However, we are having a thing called Database World, and Database World is the virtual equivalent of Oracle Open World. Huge amount of speakers from inside the Oracle organization. If you've been to any of the Dev Live events throughout the year, it's similar. It'll be a virtual event, but we'll be there live for Q&A and discussions as well. So it's as close to live as we can get it. And we'll have dedicated resources there for all the topics, database, Apex, tools, etc. So keep your eyes on that one. The agenda's been announced, and wherever you are in the world, you'll be able to participate because we've got it in the US, Europe, and APAC as well. So you don't have to get out of bed at 2 a.m. to do anything. And we've got Juan Loaiza, Andy Mendelsohn, and me. That's the other database development experts I didn't warrant a name. Okay, last month I spoke the big news, 21C had come out. 21C database, you can download, run it on premises. So there's the blog post, just wanted to reiterate that. But as I said last month as well, check out that link, the Should You 21C. It takes you to one of my videos, which talks about should you be running 21C? And it talks about the caveats of being on 19C, the long-term support release, versus 21C, the innovation release. But what a great time to be doing an office hours, because literally, 36 hours ago, we launched 21C Express Edition. People were giving me a hard time on Twitter because I said it would be coming out soon at the last office hours. Everyone was bagging me, saying soon was not a date, which is true. But I'm pleased to announce, Gerald announced it before he disappeared on vacation. It's out now. You can download it. We're going to do some demos tonight on 21C XC just to prove that it's a real thing. Literally, if you go to that blog post there, it gives you the links to the download stuff, etc. Speaking of downloads, you notice that normally on an Oracle download, there's a little tiny padlock next to the download sign, which means you have to have a single sign-on account and click the license terms. 21C XC, like many other facilities now in Oracle, part of the new Oracle initiative, effectively you just download them and go. So literally click and go. If you're looking for a guide on how to install 21C XC, I installed it just the other day and took a screenshot while I did it. So if you go to that link, it'll take you to a YouTube video of mine. It literally is just 2 RPMs, the pre-install RPM, then the 21C RPM, and at the end of it, you run a configure command and your database is up and running. It literally is that simple. Before someone jumps on the chat line, the Windows version of 21XC is coming soon. In the same way that 21C for Linux Express Edition came out about a month after 21C on premises, I would expect that once the 21C Windows general release comes out, then probably Express Edition, I'm guessing probably a month or so after that. So it's coming, don't panic. But even so, you can run 21C XC on Linux, just grab VirtualBox and off you go. A quick tip, once you do install 21C XC, this is just a bit of an omission, in my opinion, in the tnsnames.aura. I blogged about this today, if you're one of those dinosaurs that still likes using tnsnames.aura as opposed to the easy connect syntax, one of the things we do at install time is we put an entry in the tnsnames.aura for XE and the service of XE, which of course is the root container. Most of your work, connections, etc., will be done in the pluggable database under Express Edition. So jump into your tnsnames.aura, add an entry there. I've just called mine PDB1, and it will talk to the service name of XE PDB1. That's the connection you'll be using most often. You'll see that in some of the demos we do later on. But add that in, and don't forget 21CXE, just like 21C, uses the new read-only Oracle Homes format. So that tnsnames.aura file won't be under Oracle Home Network Admin. Go under Oracle Base, under the Homes folder, and you'll find the TNSNames entries under there. And once finally a little bit of self-promotion, the podcast continues chugging along. My latest episode is how to ask questions. One of the things I think is an art form that is sadly being lost nowadays is the ability to articulate tech questions such that experts in the community, wherever they come from and whatever products they use, can help you quickly and efficiently. So check out the podcast and please leave your thoughts and comments in the chat there, or you can just hit me up on Twitter. As always, these office hours sessions come from questions from the community. And as I always say every month, if you want a dedicated office hours session for your own customer with your own topics, just reach out to me and we can either do one myself or I can put you in touch with the right product managers inside Oracle to talk directly to you on the topics that concern you most. Last little bit of bits and pieces. As always, the secret to getting our communities back to in-person events so we can network, so we can share and just enjoy each other's companies is getting ourselves vaccinated. So please, we want our communities to be back. Make sure you get vaccinated, follow all your local guidelines. Whatever you do, don't watch the news in Australia where it's just turning into a bit of a ridiculous farce. But hopefully all that we can be put behind us and we'll all be meeting each other again soon because big conferences are coming and they're slowly eking their way back to being in person. I presented virtually at the Polish Oracle User Group just a few weeks ago, but that was actually an in-person or hybrid event. And seeing some of the photos from that event just reassures me that in-person events are coming. Whew, that's a lot of bits and pieces, a lot of updates, in particular the 21C Express Edition stuff. Quick chat, make sure my chat line's not full. Good. What are we going to cover this evening in the remaining time? An index status with interval partitions, one we didn't get to last month, so it's top of the list. Gap-free sequences. I'm already doing the facepalm, but we'll talk about gap-free sequences. Data management on autonomous. How to unload data quickly. Sometimes we want to unload data not with data pump. The entry point cost. If I want to get started with Oracle, what's it going to cost me? Query runs slow and then it starts to run fast, all by itself. And query runs fast and then it starts to run slow, all by itself. As always, probably best if you put your questions in the chat line. I tend to see that a bit more easily than the Q&A line, but either way, we'll try to get to them. Apologies in advance if I sort of get a little bit delayed as I look back and forth trying to find them. Okay, let's get going. Unusable indexes when it comes to partitioned tables where we use the interval clause. Here's the question that came in. In our data warehouse, I try to follow the best practice by setting indexes unto unusable as before I load in data. But since we converted to interval-based partitioning to make our maintenance easier, because as DBAs, we hate being called in the middle of the night because we forgot to add partitions in advance, we found that you cannot use unusable indexes with interval partitions. Are there any workarounds? And this is the part that really grabbed my interest, that we cannot use unusable indexes with interval partition tables. That struck me as odd. That's not something I'd ever seen in the documentation. So I thought I'd explore, and I found that particular element of the question is not actually true. We can trivially prove that with just simply creating a table. Here's a table there. I've partitioned it by range, but I've got the interval clause in there, so it's an interval partitioned table. I can create an index on it. I'll make it a local index. Global doesn't really matter. And I can either make the entire index unusable, or in this case, because it's a local index, I can do alter index model for partition P1 unusable, and it works. There's no errors, there's no problems. So the question is, why did this person seem to have this issue? It can be a little bit tricky, and that's what I thought I'd focus on with our first demo tonight, to actually look at, why partitioning, when it comes to interval partitioning, takes a little bit more care when we get around to trying to get the best practice out of loading with unusable indexes. So let's jump into a demo. Let me do a fresh share. Let's first of all prove that if you're not using interval partitions, just stock standard range partitions, the whole process is trivial. I've got a table here called T. It's got two partitions, P1 and P2, values less than. I can create an index local unusable. If I go look at the data dictionary, you can see they're both set to unusable. It's not particularly complicated. And as a result, loading data is breathtakingly fast, and I can commit. And at the end of the job, the indexes are still unusable, which is exactly what I want. And then I would rebuild them, set the indexes unusable, load your data, rebuild them at the end. It's the fastest way of mass loading data into your database, probably the caveat being exchange partition being an option. So without interval partitioning, it's trivial. And this is probably what our poster has been using up until now. Obviously, the cost of that is you have to manually create those ranges yourself. And if you forget, you can get problems. At the end of it, you can see the indexes are all usable. So let's now explore the exact same set of demos, but with interval partitions. So now I've only created the one partition, which is P1, and I've got an interval size of 100,000. So when I load in the same data, I'm actually going to get the same result here, two partitions, one P1 and the other one being automatically created as an interval partition. I create an index, local unusable, and I can check that the status of P1, the index is currently unusable, exactly the same as the previous demo. But of course, we haven't created the new partition yet because we haven't loaded any data which would enact a new interval partition to be built. So I load in a couple of 100,000 rows. The first 100,000 will fit into P1. The next 100,000 will require a new partition. And here's where this person was having some problems. The moment we create an interval partition, a brand new one, as data comes in, as the database demands a new space to store the data, any indexes that are required are immediately created as usable. Therefore, half this data went in without the overhead of having an index, but the other half didn't. The moment that new index, that new partition came online, it had a usable index and we incurred a performance cost to load that data in. But we didn't have a chance to intercept it. We didn't manage to pre-create anything. We could actually pre-create interval partitions. There's some syntax you can use to do that, but then you're almost back in the same context of, well, why wouldn't I just use range partitions? The whole concept of interval partitions is not having to worry about that. So the way we can solve it is with partial indexing, and this is the way we can tackle it. And it's just one of those things where probably partial indexing was not originally designed for this purpose. It was actually designed for only having index segments on certain partitions, but we can take advantage of it here to work around this idiosyncrasy. So I've dropped the table and I've created it again. This time I've got the same partition, P1, same interval, but I've said indexing is off, which means I can use the partial indexing concept to actually control things a bit more with a bit more granularity. So I create an index local unusable as before, indexing partial. The indexing partial is important because then it tells the index to respect the indexing off clauses at the table level. Now partition P1 is unusable, which is fine, that's what we want. Now we load in our 200,000 rows of data and notice that the interval partition also is set to unusable. This is a little bit of sort of semantic trickery here. In reality, what's happened is we've actually told the database we don't want indexing on those two particular partitions, and the way that that's implemented is to set them to unusable. That's how the database does it. So as a result, we've managed to load the data with the indexes set to unusable, which is what we wanted to achieve. I can then rebuild partition P1. That's no problems. I know what the partition name is. Now I need to rebuild the second partition. Now, as you know, I could go look it up. I can see that it's sys P2, etc. But if I'm writing an automated job, I don't want to have to go query the dictionary for that. So how do I know? Anyone that's familiar with interval partitions knows that you can actually use the for syntax and just nominate a partition key value. However, when you try to do that with an alter index command, it's not supported. You have to explicitly nominate a partition with an alter index command. So now I have to go look up sys P2 1967, etc. and work it out. That seems a bit of a hassle. However, the for syntax does work for alter table commands. So I can do alter table modify partition for nominate a partition key, 150,000 would give me partition sys P2, etc. And then say rebuild unusable local indexes. So even though it doesn't work for alter index, it does work for alter table. And now my indexes have both become usable. So there's the example of how we can now get around this. We can still have an interval partition table and we can load the data and then rebuild the indexes at the end. Just to prove what's going on here, if I alter the partition P1 unusable, which sets the status to unusable, this reinforces now one last gotcha that applies to all indexes that are unusable, whether they are interval, local, global, etc. If you truncate a table or truncate a partition of a table, the associated index or index partitions immediately become usable again. One of the most common mistakes I see people with their data warehouse loads is they go truncate a partition. Sorry, my mistake. One of the most common mistakes I see when people do data warehouse loads is they go alter the index unusable, tick, truncate the partition. They don't know they've just made the index usable again, and then go ahead and load. So it's important to get the order right. If you're going to truncate a partition, you truncate first and then you set to unusable, because in all cases, a truncate will silently flick index statuses back to usable. Even if I do indexing off, so in this case, I've done multiple, this is how I set the other partition to turn off indexing. Right now it becomes unusable. I do a truncate, it still goes back to usable. So even doing partial indexing with indexing off still does not escape the trap of truncate, making indexes usable. I think that latter example there is actually been logged as a bug inside Oracle, and we're hoping to address that. But as long as you truncate first, set unusable second, then you'll be fine. But in any way, you can see that is a mechanism via which, yes, we can still have the benefits of interval partitioning, and we can still control the indexes using partial indexes to make sure that the partitions are unusable before we load our data, to maximize the performance, and then we rebuild them afterwards. So it can be done, it just requires a little bit of finesse. Let's go back to the yarn. So as I said, as always, be wary of truncate. It's the most common gotcha when people have performance problems when they're doing database loads. And when all else fails, one of the things I would do as part of any data warehouse loading program is just have a validation step. Whenever I'm about to load some data, the first thing I do is issue a command to set my index unusable. Then I'm probably going to go query the data dictionary just to make sense. Even if it's just a case of logging it to my logging table or log file, it's always useful to have that extra bit of validation just in case you get in that random situation where you think the indexes aren't being kept maintained, and all of a sudden your load performance is incredibly slow because those indexes have somehow become usable again. So when in doubt, query the data dictionary. Okay, if you're a dinosaur of the Oracle industry like myself, this is a argument, battle, debate, discussion, insert collaborative term here, that's aged for many, many years. The concept of gap-free sequences. So it is a bit of a broken record for us who are older in the database industry, but the reality is this question came in and it's obviously someone who's perhaps fresh to Oracle. And so I thought it's worthwhile tackling because it would be remiss of me to sit there and say, well, just because I've used Oracle for way too many years, that everyone else should have the same experience as well. So here's the question that came in. We have a management requirement. It's always a management requirement, isn't it? We have a management requirement that all invoice numbers must be sequential and gaps must not be allowed. How can we ensure that sequences will fill this need? There's a very simple response to this, and it's just don't. The moment you sit there and embark upon this crusade of having no gaps, generally the pain it's going to cause you is going to be far worse than any perceived benefits. And often, I think the solution to this is a non-technical solution. The solution is a communication solution. It's often the case of getting some people in a room and exploring what is the deal? Why is there an issue with gaps? Sometimes it's an issue with the size of the gaps because sequences are cached, and that's something that you can solve with pinning sequences. Sometimes it's just one of those things where, well, where our tech stack is replicating an old manual process where we had physically printed, for example, invoice numbers or something which has a unique number on it, and we want to replicate that. But if you can have a discussion with management, stakeholders, etc., about what the actual requirements is, often you can win them over and say, look, as long as it's unique, we're good. Probably the caveat to that, oh, some chat, somebody here. Someone said, why would you need that? Implement something else for continuous sequences rather than sequences. That's a very good point. And probably the other one that comes in is people saying, well, we have an auditor that comes in and they're demanding to see evidence of why we have these gaps. And that's probably the only caveat is sometimes it's hard to convince an auditor that having literally gaps in numbers isn't really an indication that you've lost data. One would imagine you have, no pun intended, all the checks and balances in place to say, well, I filled 10,000 invoices this year. I have 10,000 invoices in my table. Who cares what the numbers are? As long as the counts match up, surely we're good to go. But let's proceed onwards. If you need to preserve the order, as in when I get an invoice number, it has to be the first one, the next person gets the second one, etc. That pretty much is the death of any computer system, in my opinion, because this is what happens. The moment someone starts an active transaction on your Oracle database and they get invoice number 1, preserving order means no one else gets an invoice number. No one else can have number 2 because active transaction number 1 may fail. It may roll back, the database may crash, etc. You literally must wait for all subsequent activities until someone commits or rolls back transaction number 1. So if you have to guarantee the preservation of order, then you've effectively reduced your system to a single user system. And, as much as I love using Oracle, I wouldn't use Oracle for a single user system. I'd just basically fire up an Excel spreadsheet, tell someone that lock the spreadsheet when you open it up, and that's how you allocate invoice numbers, because literally that's the kind of performance you're going to get as well. You've literally turned your system into a one user system. If you can sacrifice order, in the sense that someone might get invoice number 4, someone else might in number 7, but someone else is just going to get 5 and 6. We're going to fill in all the gaps, just not necessarily in order, but we will ultimately get all the gaps filled. Then that is something we can work with. You can't use an Oracle sequence for that because they're not designed in that way, but there are implementations if you really have to go down this path. And I keep stressing, it's generally a bad idea. But let's look at a demo now to show how you could come up with what I call a compromise solution that's still relatively scalable. So if you need to implement gap-free sequences, using sequences isn't the way it's going to work. You have to implement your own. So we're going to do a little bit of code here, and this is something that you can simply literally take. I'll put this on my office hours scripts under GitHub. I'll put this under my office hours scripts under GitHub, and anyone can use this as they want. So I need a table of the different sequences I'll have in my database. I've created a table called seeks. I've made an organization index because I want this thing to be ultra lean to go retrieve from. I'll create 5 sequences. I've given them wonderfully meaningful names of sequence 1 through 5. Clearly in a real life situation, you would put whatever names make sense to you here. Maybe one for invoices, maybe one for other purchase order numbers, etc. Whatever sequences you needed, that you still had to have this what I call yucky gap-free solution. The secret to having a scalable gap-free solution is to pre-allocate your sequence numbers. Now you might be thinking, well, that's going to be incredibly costly, but reality, a number is typically a couple of bytes inside the Oracle database, internal, maybe 3 bytes. If you create 1 million invoice numbers in advance, you've just burned 4 megabytes. That's not a problem. That's not even a flash drive nowadays. In fact, it's not even, it's nothing. So what you want to do is, we have this table now called sequence numbers, and there'll be effectively a range of numbers, as many as you require for each of the sequences you created in your seeks table. You can see this is also organization index, and it refers back to the sequences table. So this is a child table. In this case, for each of my sequences, I'm going to insert up to 1,000 pre-allocated numbers. So I'm running a very small business. I don't expect more than 1,000 invoices number this year. But that's an example. So you could literally create as many as you want. And if this is one of those things that needs to reset each year and those kind of requirements as well, then this is a mechanism by which you could do it. You simply reallocate the numbers at the start of each year, etc. So if we look at what's in our table now, our sequence numbers table, what we've got is all the pre-allocated sequence numbers for each sequence for the year, for the month, etc. And they all have a state. The state is, I'm free. I'm currently eligible for use. And this is the critical part, because they're all pre-allocated, now we'll be able to give them out to people in a nice, efficient manner. So the first thing I'm going to do is build a function that everyone's going to be able to call called getASequenceNumber. And this is where the magic happens. We're going to take advantage of a similar internal facility that advanced queuing uses. And advanced queuing is a similar concept. How do I farm out messages to people, making sure no one gets the same message? So what we're going to do is every time someone asks for a sequence, we're going to go get the sequence number for the given sequence name with the state equals free. We're going to lock that row, and we're going to skip any other rows that are currently locked. And this is the key thing here. So we're going to walk down the list of available numbers where they're free. Any numbers which have been used and committed will have a different status. But anyone which is in an active transaction, they'll still have a status of free from this person's perspective, but they'll be locked, and we're going to simply skip the locked ones. So we'll simply open that cursor, fetch the first available non-locked row, and then set its status to used. So it's fairly simple. Let's have a look at in action. I'm just using DBMS output here as a way of showing us retrieving a sequence number. So I do get a value for sequence number 1, and I get the value of 1. And we can see inside our sequence numbers table, this is currently an active transaction. In my own session, it says the state is used. This has not yet been committed, and 2, 3, 5, etc. are still free. If I ask for another sequence number, I get the value of 2, and now 1 and 2 are used. If I ask for sequence value of 3, you can see how it's going here. I get 1, 2, and 3 are all used as well. Let's now simulate a different session asking for a sequence number. So in this case, I'll simply stay in the Sql Plus session, but I'll use Pragma Autonomous Transaction. This is like another session asking for a sequence number, and they get sequence 4. The reason for that is it said, I want to get 1 because it would still see 1 as being free because the other session has not committed, but that row is locked. So it skips 1, skips 2, skips 3, finds 4, which is not locked, and locks it. In fact, you can see this session committed his change. So sequence number 4, sequence value 4, will be used and committed as used. I've now rolled back my primary session, the one that picked out sequences 1, 2, and 3. If we go look at our table, we can see the current state of play. 1 is free because we rolled back that transaction, as is 2 and 3. The autonomous session, or Pragma Autonomous Transaction session, it did commit its transaction, so 4 has been used and is gone. You can see how we're going to fill in all the gaps, but we are sacrificing order here. That's pretty much the only way you can get a scalable gap-free solution. Once again, this session asks now for a sequence number, and we ask, he'll get number 1, because it's the first available free that's not locked. And if we look, we can see now what we've got is session 1 is used, but an active transaction. Session 4 is used and was committed. But there we go. That is a very scalable gap-free solution that as the sequence numbers go on, more often than not, we're going to get them in almost ascending order, and we're going to fill in any gaps as transactions roll back, etc. So it's close to a perfect implementation. Even like this, it's nice and scalable, but it's not going to be anywhere remotely near as scalable as using sequences. So as I said, what we're doing is we are sacrificing order, but we're coming up with something which is an appropriate compromise. And I'll put this code on my GitHub account, and it's going to be relatively scalable. If you do have a lot of concurrent sessions, then obviously them all hammering away at that indexed organized table of sequence numbers is going to create a contention point there. If that is the case, if you're at that level, the first question I would ask is, if you're at that level, you probably really need sequences. But if you are at that level and can't use them, you probably want to do something like set a very high % free that scatters that index organized table over a much larger range of blocks, therefore reducing the contention. Or, for example, partition it either with a hash partition, or you could, for example, partition it by sequence name, such that people only collide on certain sequences. Whatever the choices are, really, they're all examples of simply scattering the data further so it's not so many sessions competing for the same blocks. But reality, please have the discussion first with your business stakeholders. Just don't. If you can just go to sequences, especially now that we have identity columns in 12c and above, it's just like declare column identity, the job is done. There's no code, there's no contention, there's no worries. It's just works. Often gap-free sequences is a political discussion, not a technical discussion. Okay. Good. No questions so far, which is cool. I shouldn't say no questions is cool. I said no, I'm hoping that I'm explaining things well as opposed to telling you not to ask questions. Autonomous data. Let me explain that with a little bit more clarity. The question that came in was someone who was new to autonomous. They said, all the stuff I've seen in the autonomous talks, of which I've done some as well, they talk about everything being autonomous, which would make sense. That's what our offering is. And this person said, don't get me wrong, I like the ease of creation and patching, etc. And so do I. One of the things I love is click, click, click. There's my autonomous database, as opposed to write some scripts, fire up DBCA, etc. And then someone said, but with the exception of automatic indexes, isn't it really just another database? And that's probably a fair comment, because if you look at the literature that's out around autonomous, we say, self-tuning, self-healing, self-patching, etc. And certainly the infrastructural side of things, I think we can claim to be autonomous from the perspective of the customer, i.e., you don't have to worry about backups, you don't have to worry about patching, you don't have to worry about all that infrastructural stuff. Certainly provisioning, etc., is just literally trivial. That's one of the things I love about it. But there's an argument to be made there that that's what any cloud database should be like. So what makes it the next leap to be autonomous? And automatic indexing is certainly one of those things, but is that the only thing? I think it's safe to say that we're on a journey here. And automatic indexing was probably the first thing out of the box in terms of adding more autonomy to the autonomous database. There are things going on behind the scenes. We use some of our machine learning algorithms to trawl through logs such that if customer X starts seeing some problems, that information can be used to fix up customer Y and Z in advance. So there are things behind the scenes that also have some autonomy about them, but customers generally don't see that. So in terms of bringing on a journey, we're not trying to hide anything from you. This is actually in a roadmap. You can go to the documentation. It has, these are the automatic operations that are either there or coming. This, I think, was taken from the 21C features. So these are all the things that are actually, I think, are already in there in most of your autonomous offerings, depending on what region you're in. Automatic indexing, you've seen, but automatic index optimization is coming, which is we might choose, for example, what level of compression to have on those indexes that we automatically created, or even your own. One of the things that people use so infrequently, and you can, there's advanced index compression, which is a licensed feature, but basic index compression, key compression, has been there since 8i, yet so few people use it. So that are the kind of things that we're going to maybe take on that responsibility for you. Automatic materialized views, automatic SQL tuning sets, temporary tablespace shrink. You do a monster sort and your tablespace goes out to there, and next thing you know, you get this giant file chewing up space on your file system. We're going to have a facility which will shrink that down over time. That's not such a big deal for existing DBAs, because nowadays, if that happened, you'd simply drop one temporary tablespace, create a new one, and off you go. This one's a bit bigger though. Automatic undo tablespace shrink. You do a monster transaction, it gets this big, and then the contraction's committed. Well, you've got undo segments out here at the very end of the data file now. That can be a problem because you can no longer shrink those data files. We're going to add that into Autonomous as well. Automatic zone max, object activity tracking system, sequence dynamic cache resizing. I spoke about that in a recent office hours, and also I did a blog post about this. I said, we've killed sequence contention. Even if you choose a tiny cache size now, we will dynamically adjust it as you're running your system. You could argue maybe that's not autonomous because you can get that available on premises as well. One of the things that's not listed in that list is something that actually is floating around autonomous today, which is automatic partitioning. I've got a big table, I query it regularly. Maybe there's a better option in terms of carving that data up into partitions. Now, this is fairly new, and I think at the moment we only activate it in reporting mode as opposed to implementation mode, so it simply reports on what's possible. But on your behalf, I created a autonomous data warehouse, loaded up a big chunk of data, ran the automatic partitioning thing, and actually I just thought I'd show you some of the output to give you a hint as to some of the more autonomous stuff that is coming very, very soon. So let's create a table called a part. It's going to be for automatic partitioning. Big shout out to Nigel Bayless, the Optimizer product manager. He helped me with a lot of the scripts on this demo. I'm going to insert, and what have I got there? 150 million? Yeah, 150 million rows. And if we look back at the table, I put this padding column in there, 1,000 bytes. So it's a big table. And you can see it took a couple hours to load. I'm literally doing this on the very bare bones single CPU autonomous offering you get, but it's a 100 gig table. Has to be a big table because otherwise, why would you bother partitioning it? If I look at it, it says I'm going to run some queries now because this is let's say a data warehouse table. I'm doing a lot of date range style queries. So here's some stuff for March. Here's some stuff for just one day in March. Here's some stuff between January 1st and January 5th, etc., etc., etc. I think I ran 10 different queries on this table. I didn't put timings in, perhaps I should have, but one of the things that blew me away was these were still remarkably quick because of the value of things like Exadata storage indexes. The first scan took a long time, but the rest of them actually were remarkably timely, even on my little single CPU autonomous database, because storage indexes kick in and also smart scan on storage cells, etc. All the goodies of normal Exadata came into play here. But I did all this. I said, okay, I've done a lot of queries here which are date-based. Is that enough to tell the database that maybe some partitioning is useful for this particular table? And this is the process as to what's going to happen. The database is probably going to do this a lot by itself, but I thought I'd walk it through manually for you to see what's actually going on in terms of the concept of automatic partitioning. I'm going to create a SQL set called my SQL set, and I'm saying, go get everything that my particular user, the admin user, had run in this particular database up until now. That's going to pick up those queries against my my A part table, but also everything else, obviously. So the next thing I do is I'll delete from that tuning set anything which is not select sum from A part. Therefore, I'm just isolating now the 10 queries I ran that are typical warehouse style queries with a date range, etc. If I go look at my SQL set statement now, I can see I've captured the 10 typical queries that I ran. One for a single date, the others are for betweens, etc. The first thing I do to see if a table could be automatically partitioned or autonomously partitioned is I got this thing called DBMS auto partition validate candidate table. I pass in my A part table, I pass in my SQL set of SQL statements that have been run against it, and it says, yep, there's a good chance that this would be a candidate for partitioning. There might be reasons why it not be, depending on the way the table is structured. For example, if it had particular data types, that means it couldn't be partitioned, etc. So the various checks that would normally undergo here that you would do manually are done by this particular facility. Now, I'm going to set partitioning mode here to report only. So I'm not going to actually implement any changes. I'm just going to ask the database to go ahead, just like we can do with automatic indexing, to actually go through the entire process of deciding on automatically partitioning this table, but not finally doing it. And this is how it works. I say, I'll come to this cursor shortly. The first thing I do is I say, okay, I've got R being a raw. It returns me it returns me a GUID. I want to recommend a partitioning method based on these SQL statements, based on this table. I'm just going to ask for a text report. And then once the report is finished, let me pop back to that cursor. I'm going to query my automatic partitioning recommendations for that particular key, that GUID that came back. And it ran for a long time. This ran for about, well, in fact, I think it's coming shortly. It came and it said, yes, this is what I think you should do. That table in which you did a lot of date range queries, I think we should partition it. We should partition it by list. At which point you're going, what? When would we ever partition date range things by list? Please bear with me, I'll explain. So I'm doing a list, sysop interval high bound. I'm doing a 1 month interval. That's my starting partition, and the partitioning key is the column called D. Now, why would it choose list partitioning for a date range? One of the problems in this table here is I never nominated that date was not null. As a result, I could put nulls in there. And as you know, you can't put nulls in interval partitions because they're not designed that way. So if I want to get the benefits of interval partitioning and this column can still allow nulls, I've got a bit of a conflict. To solve this issue, in Autonomous Database, we've actually built a new kind of partitioning method. It's a list format, but we put an expression around here to make sure that we never ever end up with nulls. It's actually a list partition on a function-based index, effectively, or function-based expression on the partitioning key. That has some smarts in the optimizer layer to know that even though you just do normal date range queries, if this table was indeed partitioned in this fashion, it will be able to work out how to do partition elimination. So that's why we had to use lists. We had to actually invent an interval partitioning mechanism that would cope with nullable columns. That took 3 hours to run. And that's why it's just like automatic indexing. If you've seen some of the automatic indexing slides, we don't just go, does a theoretical explain plan suggest this might be better? We actually go build indexes, test run queries, and make sure they're better. That's what's going on in automatic partitioning. We will actually build a copy of your table in a partition form and then test run those queries against that new partition table. That's obviously an expensive operation to copy your table into a partitioned equivalent. This ran for 3 hours. Once again, just single CPU. In a real autonomous database, you'd obviously be cranking it. But on a single CPU, it's going to run for a long time because we don't like being iffy. We don't like being vague. We are going to guarantee that we can quantify the benefits, if any, of moving this table to partitioning. That's one of the cool things. We're cautious. Same with automatic indexing. Lots of caution to make sure that we guarantee the results we're getting. And then out comes the report. And the report is comprehensive. If there's one thing I can say, it's ridiculously comprehensive. It starts off with we ran it as a system task. It has some bits and pieces there. That's the key name, the GUID that came out. It goes through all the bits and pieces. It talks about what the impact is. Things have to be, if a SQL is impacting more than 1% of the overall load, then that's a candidate, et cetera, et cetera. But then it comes up with a sort of a summary. It says, I reckon that if we partition this table, we'll have an improvement of 91% on the response time of those SQL statements that we considered, those 10 SQL statements. And it tells you there was 10 there that we looked at. And then it lists them. There's the SQL IDs. It says, here's the improvement. I had 92% improvement. These are all fairly predictable because I went from a year of data and all these queries ended up scanning a 1 month. Therefore, 1/12 of the data. So about 8% of the data needs to be scanned, therefore a 92% improvement. And then for each of those SQLs, it says, here's your SQL ID, here's the SQL statement, here's all the bits and pieces on before and after. You can see we test ran them on the old table, and then we test ran them on the new table to see what the benefits are. And we have elapsed time, pass time, and we get that for every single SQL statement, including we get the execution plan before the table was partitioned, or its version would be. So yep, that's what the query looks like before, just a normal Exadata smart scan. And then afterwards, against our template table, it would be partition list single. And therefore, that's the benefit we saw. And you get that, the stats, the before plan, after plan for every single SQL statement, and we're done. The reason I made my table so big is because we have a 64 gigabyte entry point. That is configurable, but that's what we recommend. Anything less than 64 gigabytes probably isn't worth partitioning on an Exadata system because the speed at which we consume data on Exadata is just insane. And therefore, I think we're up to about 20 gigabytes per per second now. So really, you have to have a big table to make it worthwhile. You just said you can put null in a range partition if you have max value. Yes, but you can't convert a max value range partition table to an interval partition table, which is why we had that issue. But yeah, excellent for pointing that out. Thanks, Judith. So I suppose the key thing is the reason we're being very cautious with automatic partitioning in terms of not just turning it on for everyone silently on autonomous is there's an important cost versus benefit relationship here. As you saw, the time it took me to evaluate the benefit of partitioning a 100 gig table was 3 hours on this system. Now, as I said, single CPU system, but even on a big system, we're going to copy that table. So if you get a 10 terabyte table, we're going to have another 10 terabytes copied there, and then we're going to smash away at it with lots of sample queries to make sure this thing is guaranteed to give you a big benefit before we actually would flick the switch. Just like automatic indexes, caution, 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 because we never want to have a regression. We only want to have a positive result. So be aware that that's the reason we're cautious on this is there's a cost versus benefit here. You want to get big benefits, but we're going to burn a lot of resources here to make sure those benefits are realized. More enhancements are coming. You'll see more and more things that have the word automatic in them in the autonomous offerings because we are heading toward that genuine utopian goal of a database that literally makes decisions on its own right to make life better for you as developers and as DBAs. What have we got? 10 minutes left. We can probably get one more done. And we'll skip a few for next month. Unloading data. Well, this seems to be a no-brainer, doesn't it? To unload data, you use data pump. The job is done. It's nice and fast. You can run it in parallel. It's super quick. Fantastic. This is the question that came in. What is the fastest way to unload Oracle data to flat files, for example, CSV format? I can't use data pump because this data is being provided to a third party that does not use Oracle. Now, when it comes to not using data pump, the solution here, in my view, is obvious. That is, you find a third party that is using Oracle and the job is done. Yeah, just kidding. I understand the reality is there are needs sometimes to get your data out of an Oracle database into a format that is not going to be used by Oracle moving forward. So I thought I'd show some demos here, but this is all about really about the volume of data you need to unload, versus the ease and flexibility. The more data you have to unload, the more work you generally have to put in to get the benefits. And we'll explore this with a demo now. So let's go demo. We'll get this done hopefully by the end of the day. And let's do a new share. And this is all going to be done with 21C Express Edition, just a running version, running under Linux, under VirtualBox here. So it won't be breathtakingly fast because it's a VM running on a laptop, etc. But we'll get enough of a comparison here. So let's start off with the easiest way to unload data is generally with SQL CL. Now, we connect here. We connected to 21C Express Edition. I'll set this running and then I'll explain the script as we go. So the first thing the script does is print itself out so you can see what it's doing. We're going to set array size to 20. And then we're going to check out the current time, unload some data, and then get the current time again. And obviously the difference is going to be the elapsed time. What are we unloading? We're going to unload scott.emp and we're going to unload 20,000 copies of it. Now in the other demos, we're going to unload 100,000 copies of it. So this is actually 1/5 the scale of what the other demos are going to be. And the reason I had to do that is because it takes a little bit of time here. I didn't want to waste your time. So SQL CL can be a bit slow for larger volumes, but the ease is fantastic because literally you simply put this special hint in here. Select CSV. It's not a plus hint, it's just the actual comment CSV. SQL CL knows that. It's a special thing. And what do we got? We got 5208, 52, about 26 seconds. That sound about right? 26 seconds for 1/5 the scale. So the others are going to be 100,000 copies. So if we times this by 5, we get 130 seconds. Takes just over 2 minutes to unload, in this case, 20,000 copies of scott.emp. So it takes about 2 minutes. To do 100,000 copies, it would take about 2 minutes. It took 26 seconds for 1/5 of that. So yeah, 100,000 copies, that's 1.4 million rows. Takes about 2 minutes in SQL CL, but the ability to do it is trivial. You literally type in, comment CSV and the job's done. So for small volumes, that's perfect. 2 minutes might be getting a bit slow for 1.4 million records. So SQL P is just an alias for SQL Plus. I'm just a lazy typist. So how about SQL Plus? So in SQL Plus, in the later editions from 18C onwards, we have almost as easy as SQL CL. We have this thing called set markup CSV on. And that says all queries from that point onwards will now effectively put the output as CSV as opposed to just in normal rows. So we'll set this one running. And we saw before, so you can see now this one, we're actually doing the genuine 100,000 copies of scott.emp. So for SQL CL, we extrapolated that would be about 2 minutes 10, 130 seconds. With SQL Plus, because it's not a Java program, it's an OCI, it's right down in the kernel, we've got about 13 seconds. So 13 seconds for 1.4 million rows, we're getting about 100,000 rows per second spooled out. I'm spooling just to dev null here because obviously I'm not trying to incur the file overhead costs, especially on a VM. So about 100,000 rows per second, so 13 seconds for the 100,000 copies of scott.emp, all spooling to /dev/null. So that's pretty good. Can we do better? Well, one of the things that SQL Plus is doing is obviously reading from the database and bringing it back to the client. So we might be able to get some benefits if we went with UTL file. So let's try that. So you get out the file. Now we're getting to starting to having to write a bit more code. So to gain performance, we have to write more code. So I'll set that one going, then I'll explain what's going on. We've got a UTL file type. We open up to demo. Oh, I was like, I need to cancel this. I forgot something. Let me start again. Because I want to write to dev null, you can't do that with UTL file. So I'm going to cheat because I don't want to. Let's start again. What I've done is I'm creating a file called demo.out, which is actually a named pipe. And then I'll cat that named pipe out to dev null. So the database will think it's spooling out to this file called demo.out, but in reality, it's being sent to dev null. And now I can run my UTL file command. Let's start that running. Because you can't simply write to /dev null straight from UTL file. because it's not a directory object. So we're writing to demo that out, which is actually a pipe, which is simply funneling it out to dev null. So we're getting almost the same as funneling to dev null. All I'm doing is 100,000 copies of scott.emp, but now it's my job to build the string. I have to do all the work in terms of building up the CS file string and then spitting out the lines. So that one took 19 seconds. So that's actually a bit slower than Sql Plus, which seems surprising. But the reason it's slower is the actual act of calling to write out a line of code is expensive. Can handle club columns. Good question, Hans. I think it can. I'd have to check. I think CSV does. I'm not sure about set markup CSV. But in both cases, what tends to happen is if there are things like hard returns and carriage returns in the club, I think we just spit them out. So then it becomes your job to try and diagnose that mess when it comes to actually reloading the CSVs. I don't think we do any magic in terms of carriage returns, line feeds, etc. So UTL file spitting out one line at a time got me 19 seconds. Sql Plus being 13 seconds natively is still the benchmark we're trying to beat. So let's run my UTL prep again, give myself another named pipe, and let's have a slightly more complicated version of UTL file. And this one says, I'm going to try defer writing lines as much as possible. So it's still the same query. But what I'm going to do is I've got this string here, which is 32,000 bytes. So what I'm going to do is simply keep concatenating a row of data to this string until it gets to almost 32K in size, which gets to the limit of how UTL file can write to. And then I'll spit out a line. So now I'm writing out a line to the file every 32 kilobytes as opposed to once for every row of data. So I'll set that running. This is probably about as good as we can get with UTL file. It's chugging away. And that one came down to 9 seconds. So that is slightly better than the Sql Plus. Sql Plus bombed out about 13 seconds. Now we're doing it entirely on the database and a bit more complexity. We're still sort of buffering up rows into a string and then dumping it out to UTL file. But we got down to 9 seconds now. Great timing, but the complexity has risen. At the sort of the very pointy end of performance, but the most complexity is we could actually write our own program. So this is what we're going to run in a second. I'm going to run this program called Oracle ASCII Unload. It only works with ASCII. I haven't done anything in terms of UTF-8, etc., because my Pro C isn't that good. And it's going to simply take in a SQL statement, the same SQL statement before, and it's going to unload it to dev null. So what is that program? If we have a look in here, what do we got? Start PC, I'm just lazy typist. It's a Pro C program. So what we've done is we've written a program here which says, okay, this is a custom program for the sole purpose of writing out CSV. Tom Kite wrote this originally back in the day. It's on Ask Tom, and we've sort of tweaked it a bit to make it actually compile and work under modern versions. But you can see it takes in various bits and pieces. And if you're unfamiliar with Pro C, what it's actually doing is actually doing the same as what we do with dynamic SQL. I can't go back, can I? Can I go back? We actually declare a cursor, prepare this SQL statement that comes in from the command line. We actually describe a list to get all the different columns, and then we go through and actually fetch and spit it all out to the file. So there's a fair bit of code in there. The complexity has now jumped a lot, but obviously once it's written, at least it's done. And now let's actually run it. So in this case, it's a nice generic program. You literally pass in the SQL statement and the array size and the user ID, and it's going to chug away, see how it goes. And it was done in 9 seconds. So it's generally as fast or a little bit faster than the UTL file version. So there's some examples of how you can actually get into unloading some data. Let's go back to the slides because we're just about out of time. So to summarize the demos we just saw, for most of your needs, SQL CL is going to be the easiest and trivial. Simply throw in your CSV, job done. It's going to be slow because it's JDBC and there's a lot of overheads, and SQL CL has to be all things to all people. It's got so many options in it. Unload to JSON, unload to XML, unload to CSV, etc. That flexibility comes with a performance cost. But for the vast majority of your things, you'll be fine just using SQL CL. It's going to do the job. If you need to maybe spruce that up, think about using, for example, DBMS Parallel Execute. That's a great way of taking a table or a query and dividing it up into logically sized segments. So even if you don't use DBMS Parallel to actually run the tasks, it's a great way of just using it to carve up a table, and you can take beginning and ending row ID ranges to then pass that to multiple concurrent versions of SQL CL, SQL Plus, etc. If you need a little bit more grunt, so to speak, SQL plus doing it in parallel is probably going to be adequate for the vast majority of jobs where SQL CL doesn't cut the mustard. So it's going to, as we saw, it got us 13 seconds for 1.4 million rows. You could probably have several of them running for different ranges of data, and it's going to be able to pump that data out very, very quickly. If you're at the very, very pointy end, you actually you have literally terabytes of data you need to get out as fast as possible. You probably want to be looking at the Pro-C solution rather than writing util-file, because the Pro-C one works for pretty much any query. Probably needs to be extended for things like interval and timestamp data types, but to get you going, it's up and running. I'll put it on my GitHub, but also you can download that today. Go to Ask Tom, click on Resources, click on Downloads, and you can just search for Unloader, and that Pro-C file is there. Just get yourself GCC, Pro-C, and off you go. Okay, we are out of time. We almost got to the other questions. Well, no, we didn't. We're getting nowhere close, but not. As always, thank you very much for your time. In particular, I could sit here and talk all night, but you'd get bored and you probably wouldn't come back for any more office hours. It's always a pleasure to have you here. Hope you found all that entertaining, useful, and of benefit to you. If you have any questions, as always, just reach out to me on Twitter, probably the easiest way. And yeah, I'll be happy to answer any questions or have any follow-ups on tonight's session. This will be available as a video as well if it all went too fast for you. As always, stay safe, stay healthy. Hopefully we'll see you in person at conferences soon. But until then, bye for now, and we'll see you next month on General Database Office Hours. Bye, everybody.